second. Hi guys, how are you all? You know what? Please excuse me, I'll switch on the video after another 15 minutes. Is that okay?
Okay.
I'm on a hotspot. If I switch on the video, a connection will be so laggy and I don't want that. As soon as I get to the proper network, I'll switch it on. Okay? And on the extended class, right? Can we do that after 2 weeks? There are a couple of kids that have not joined today and next week. So they were requesting, can we have it after 2 weeks? Can we do that?
Sure.
Yeah. So anyway, we'll get it done before summer, right? So it should not be a problem was what I thought. That's why I did not remind you guys for the extra 15 minutes, the 30 minutes today. But I'll do it as and when most of us are ready. Make sense? See, nobody has come today, right? I don't know why many of them have not come.
It could be traveling since most school ends like this week or next week.
Yeah, that's what I'm thinking actually. Or maybe, yeah, Ashwik is not in here. I don't know. I didn't get any information from, I don't know. Okay, anyway, can I move on now? Okay, did you all do 3.1, 3.2, 3.3? Did you have any questions on that? You didn't have any questions. Okay.
Oh yeah, was it the SAS congruence things?
Yeah, exactly. We did SSS, SAS. Yeah.
I think I did that somewhere in my notebooks.
Okay, so to see, there are some certain things which I want to cover, meaning the book covers a nice amount of geometry, I know that, okay, but then there are certain things that comes as a part of your school geometry which is not in here, I feel, okay, so I would want to cover that as well. So for this week, right, I really want to do something from there. Give me a minute, guys. Yep. So I really want to cover this inductive and deductive reasoning. Okay. So that I don't know whether that comes as a part of this book. Let me see. I have the book with me. Triangle, polygon, quadrilateral, circles. See, we are. Yeah, that's not the. I don't know. Yeah. Is it coming? 1 second, guys. You covered it? No, I don't see it. Okay, anyway, let's go ahead. I don't want to take up class time. Let's do this. Hold on. Let me share my screen, guys. I'll get started and then continue the congruence. You're able to see my board?
Yeah.
Okay. So we'll understand what is inductive and deductive reasoning. First of all, do you know what a conjecture is? We have discussed that, right? What a conjecture is. What is a conjecture?
A guess or something.
See, it is a generic statement. It's a generalized statement. You believe it's true, okay, based on personal experience or observing some pattern that you have seen. You think it is true, but it can be proven false. Make sense? Meaning, a conjecture is a generalized statement. So now, what is the difference between a conjecture? Let's see. What is the difference between a conjecture, axiom, postulate? What's the difference between these?
Postulate is a universal,
Do you know what's the
fact.
Fact that is accepted to be true.
Yeah.
Makes sense. Axiom and postulate refer to the same thing. They both are one and the same. Axiom and postulate refer to the same thing. They are generalized statements that we accept them as, oh yeah, this is true whatsoever. It's given to me and I accept as is. It's true. Okay, but whereas a conjecture is again a generalized statement which may or may not be true. It's not an accepted statement that's true, but it can be true or it can be proven false. You got it? So let's say this one. Okay, let me come up with all prime numbers. Let's say this. All prime numbers are odd. Now, is it conjecture, axiom, or postulate?
Conjecture. Conjecture. Because that 2
Yeah.
is
Why?
because that 2 is a even number, but it's prime.
Exactly. So yes, it is definitely a conjecture. Okay, because it is not an accepted statement. Meaning all prime numbers are odd is not an accepted statement at all. Okay, so it is a general statement. Okay, but it can be proven true or it can be proven false. Okay, so as I said, right, it can be true or it can be false. Okay, here you just now Anish said that the number 2, right? The number 2 is an example that does not obey the statement. Okay, so the conjecture is false, and you know what is this 2 called? This 2 is called a counterexample. Any questions? Any questions? So sometimes, meaning you can prove a conjecture to be true or false. One famous way, one very popular way of proving a conjecture as false, conjectures can be proven to be false if you are able to get a counterexample. Make sense? This is one way of proving the conjecture to be false. Make sense? Can I move on? Okay. Now, let me take this out. Okay. Now, let's go ahead and find out. See, first of all, I would like you to understand in geometry, right, there are 2 types of reasoning. One is inductive reasoning, the other one is deductive reasoning. Okay, see this one. Inductive reasoning is looking for a trend or pattern or observing certain things. Okay, this bus comes at 6:10 a.m. to this stop on Wednesdays. Every Wednesday for 2-3 weeks you sit and wait at the bus stop and see this bus comes at 6:10 a.m. on Wednesdays every week. So you observe this pattern and say, hey, this bus number 110, let's say the bus number is 110. This bus number 110 comes to this bus stop on Wednesdays at 6:10 a.m. So you come to the conclusion that this bus is going to come on Wednesdays at this bus stop, right? So how do you conclude that? You see the pattern, you observe it for several weeks, and finally you come up with a generalized statement. Hey, yes, so you see the trend, you observe a pattern and make a statement, right? You generalize a hypothesis. So that is called inductive reasoning. Did you get it? We are going to study 2 types of reasoning. Okay, one is inductive reasoning. Now we'll go for more examples of inductive reasoning. Okay, 1, 3, 6, 10. Let's see this one. I will give you a pattern.
You're quite laggy.
Yeah.
Then you can make a conjecture about the next number. 1.
Could you please
What's the
repeat what
next
you
number?
said?
No, what is the next number? See, using inductive reasoning, you are going to find out the next number in this pattern. What is the next number in this pattern? Wait. 9. It was my bad.
81.
Yep.
Yeah,
So
81.
this is inductive reasoning. Yeah, what you did was inductive reasoning. Did you get it? How about this? 1, 6 by 5, 7 by 5, Okay, 8 by 5. 1 minute, guys. 1. Let me give you more. Have 6 by 5, 7
Miss
by
Priya,
5.
you're lagging
1
like a
second,
lot.
guys.
Yeah.
6 by 5. Give me another 5 minutes, I'll be fine. What is the next number in this pattern?
9 by
9
5.
over 5?
9 by 5. So this is inductive reasoning. How did you get that? So you're looking at the pattern. 5 by 5, 6 by 5, 7 by 5. 8 by... This is inductive reasoning. Okay. So now let's go ahead and try this one. Let's try this one. Okay. Okay, let's try this one. I have talked to you about counterexample, right? So let's see this one. Okay, I'm going to give you this. Let me erase everything off. How about this? Given A, B, C are collinear. What does collinear means? What does collinear mean?
They're lying on like the same line.
Yep. The points in this collinear means A, B are collinear. You see here, A, B are collinear means lie on the same line. What does coplanar mean?
Lie on the same plane.
Yep, lie on the same plane is coplanar. Good. Now, points A, B, C are collinear. Okay. When A, B, C are collinear, let me put it in the same line. Give me another 2 minutes, guys. I should be fine. Okay. A, B, C are collinear. Now, AB plus BC equal to AC. AB plus B. Is this conjecture true or false?
What?
Is this conjecture true or false? See, this is the statement. Okay. A, B, C are collinear. Okay. Now, A, B, C are collinear is a fact that's given to you. Okay. I am writing out a conjecture AB plus BC equal to AC. Is the conjecture true or false?
True.
This is my diagram. You can draw your own diagram and check.
Would it not be true if it was A, C, and then B, like the points are on different parts? Like instead of B being in the middle, if C was in the middle, wouldn't that make it false? Miss Priya?
No. Because if it's
In a
true.
case where I have A, this conjecture is false.
Yeah.
No.
It's not
So
true, right?
Yeah, it's not true because if it's
Why?
C is like in between A and B, then
Why
it won't
it's
make sense.
Okay.
have a counter example. Do you get it? I have a counter example where I am drawing A, C, B points as collinear points on the same line. Okay, clearly. But in this counter example, AB plus BC is not equal to AC. Since I have a counter example that can prove that the conjecture is wrong, I can say that the conjecture is false. Make sense? Okay, let's find out one more. So we are just using counter examples to prove true or false conjectures. How about this? You're going to try, guys. Okay. How about this? You're going to tell me whether I'm going to give you a conjecture. Try this one. Given R and S are supplementary. What does supplementary mean?
Equals
180
180.
added up. When
Correct.
R
So
and S are added up, it's 180.
Correct. And R and T are supplementary. Okay, those are the facts that are given. But conjecture is T and S are congruent.
No, that's false because
No, it's
If
true.
you say it is false, I need to see a counterexample.
Because that
It's true.
is true. Because that R and S could be anything. So like if R was 91 and S was 89.
Let's try.
and
Let's try.
T-
Let's try. Let's try. So you're
Wait,
saying
I see. Wait, I didn't realize that R was the same for both of them.
Yeah.
yeah.
So
What do you
R is
think?
the same, so it can't be two.
Yeah.
It can't be two different.
So what do you think? Conjecture is true or false?
It's
True.
I think
True.
it's
True. Good job. See here. R and S are supplementary. Let's do it.
okay.
R and S are supplementary. R, you get it?
Yeah.
E and S are definitely congruent, right?
Mhm.
Okay, let me give you. Let me give you.
Mm.
Sorry guys, okay, I'm switching connection, that's why it got disconnected. Okay, so let me switch on the video and stuff. I switched connection, so we should be good now. You're able to see me? Yep. Let's go ahead with this one. Okay, so let's go ahead with one more. How about this? Tell me how about this. Okay. You're going to tell me about the conjecture, true or false. You're going to give me, if the conjecture is true, then I need some example. If the conjecture is false, I need a counter example. Can you try that? You'll feel better once you take it. Are you cold? Huh? Come on, wait. I have a solution.
Can I not be?
It's true. I believe it's true.
Think
Yeah,
it's
I
true?
think it's true too. I have an example.
I mean,
A, B, C and D, E, F are supplementary. Not necessarily. Why? A, B, C, A, B, C and D, E, F are supplementary. Is this not a counterexample, guys? If I draw it like this, yes. A, B, C, D, E, F. In this case, yes. In this case, this is an example. This is a counterexample. This is not a linear pair. They don't form a line. Am I making sense?
Yeah.
So is this true or false?
False.
false.
False. So the conjecture is false. Can I move on? Can I move on? So this is a nice part of geometry, easy part of geometry. We'll continue with congruence. Okay, can I move on?
Mhm.
Okay, how about this? Okay, so we using counter examples we can prove that the conjectures are false. Okay, now let's go ahead and try this one. We did inductive reasoning, right? Now let's see this one. Yeah, how about this? How about this? Find the rule for the number of dots. Meaning you should be able to find the rule for the number. These are all inductive reasoning. Okay. We'll go to deductive reasoning. That is the most important one. How about this? Find the rule that can be used to determine the number of dots. What is the rule in general? What is the rule? Meaning, write down 1, 2, 3, 4. You have 3 dots. Then you have 3, 4, 5, 6 dots. So keep doing that and let me know what is the nth rule. Stage n, how many dots? Would you be able to try? This is inductive reasoning, guys.
Yeah.
What happened?
N times 3 equals dots.
Good job. The nth rule is 3n. This is all based on inductive reasoning. Make sense? Okay, how about this? I want to give you a hard one. Let's see. Wait. This one is good. Let's see. How about this? Let's find out one more. What is the nth rule? This is 3n. So this is for this one. Now what is the nth rule for this one?
N by n plus 1.
N by n. What is that meaning? N times n plus 1 you mean?
Yeah, and like on this side,
N times.
what's
Yep.
it? The length is gonna be n, and the width is gonna be n plus 1.
Yep, n times n plus 1. So if you are
Yeah.
able to do this, that's great, okay? Meaning you just need to be able to write out the nth term rule based on inductive reasoning. Okay, see, the thing is, this is not a part of the book, okay, but 100% your school covers this, and I don't want you to be like, oh my god, auntie did not cover this, okay? So that's why I thought of bringing it up in between. There will be many other topics like this that I bring it in between like this, okay? The book is great though, but I don't know, it doesn't cover every single piece of what needs to be covered. Okay, now let's see this one. Identifying patterns, you take care, guys. I think you should be able to do this. Okay, now let's go to conditional statements. Okay, this is the most important piece. I'll give a separate assignment on these, guys. These are not, yeah, you won't have it in the book though. Coming to conditional statements. What are these? In geometry, what are these conditional statements? Any if-then statement. Any if-then statements is a conditional statement. Let me write it down for you. Any if-then statement. Okay. Now, this is the way. You know how to read this? This is the way you symbolically represent conditional statements. If P, then Q. You got it? Makes sense? This is a conditional statement. Now, if it is Saturday, then there is no school. Let's see. Let's see an example. If it is Saturday, then there is no school. This is a nice part of geometry, guys, okay? But once you understand, it's very easy. Okay, so now what is this? What is this? This is clearly a conditional statement because it has if and a then statement, correct? Now, there are two parts of a conditional statement. Okay, this part is called the hypothesis. This part is called the conclusion. Any questions? So this part is called the hypothesis. This part is called the conclusion. Make sense? Okay. Now, how about this? You are going to tell me which is the conclusion. Which is the conclusion in this conditional statement? I'm going to ask you for a polygon is a rectangle if it has 4 right angles. Which is the conclusion?
The first part.
Yes, here the first part is the conclusion. Whatever follows the if is the hypothesis. The conclusion is the conclusion you make from the hypothesis. Make sense? So a polygon is a rectangle is the conclusion. Make sense?
But it could also be a square
Okay.
or trap. I mean, not trap.
Yeah, it can be. Yes, it can. See, this one is just a statement. I'm just telling you what is a conditional statement, which is hypothesis, which is the conclusion. That's all. Okay. Now let's see. How about this? How about this? Suppose if I give you a statement, can you write it as a conditional statement? I give you a statement. I want you to write I'm giving you a statement. Each word is important, guys. I'm giving you a statement, okay? I'm giving you a statement. I want you to write a conditional statement out of this. How?
But if the sum of the angles is 90, then the angles are complementary.
Nice. So so how do we start it? What is given here? The sum of the measures of complementary angles is 90 degree. If two angles are complementary, then their sum is 90 degrees. Make sense? Does it make sense? Okay. Okay, now how about this? Okay, now comes the very important part, guys. I'll give you a conditional statement. Okay, there are 4 things which we are going to study. One is a conditional, converse, inverse, and contrapositive. This is the important part. Okay, so here let's see the conditional. Okay, I'll write it down for you, each of those. I'm giving you a conditional. This is the conditional statement. The conditional statement is if angle A is equal to acute, then measure of angle A is equal to 35 degrees. Now, you can do a converse, inverse, contrapositive. Okay, there are 3 other things which you can write. Okay, now as we said earlier, this is if P then Q, right? Now let me tell you what a converse, inverse, and contrapositive is. Then you can tell me, or then you can literally write down the others. Okay, now the converse says if Q then P, meaning conditional says if hypothesis then conclusion, correct? Converse is just the opposite. You misplace. You just switch the conclusion and the hypothesis. If Q, then P. Okay. Now, let me write it down for you. Here, if Q, then P. Okay. You know what is this inverse? Not P, not Q. Not P, not Q. That means what?
If it's not correct, then it's not true.
Correct. That's how you need to change it. Okay. Then what is the last one? Contrapositive is if not Q, then not P. See the symbols I'm using, that is very important. Okay. Now go ahead and tell me what each of this is. What is the converse? Can we write the converse? Let's write the converse. What is
If A equals 35, then
measure of A equal to 35?
then A is acute or equals acute.
Angle A is acute. Good job. How about inverse?
If A not acute, then A
If
not. If
angle
A
A is not acute, correct.
is not acute, then angle A is not equal to 35.
Don't worry about whether it's true or false. Don't worry about whether the statement makes sense or not. Don't worry about it at all. We'll go there. Then the contrapositive.
So if the measure of angle A is not 35, then angle A is not acute.
Yeah. But these are all making weird sense. It doesn't make any sense right now. Wait, let's see. A is not acute. Okay. Now, we are going to discuss a new thing to all these. Once we discuss, you should be very clear. Okay. We'll move on. Okay. We'll never turn back, but this is very important part of geometry. Okay. You will be asked a ton of questions in your whatever exam at school. So here there is something called a truth value. Truth value. You know what is this truth value? Truth value is whether the statement makes any sense or not. Is it true or not? Okay, if A is an acute angle, then measure of A is 35. Is the truth value true or false?
It's true.
It's false because that if A is acute, then it equals it's false because that A could also be equal to 45.
So what are you saying, Anish? Is it true or false, the truth value?
False because that A could be equal to multiple things.
Exactly. Measure of A can be 35, 45, 36, 36.5. It doesn't have to be 35. So the truth value here is definitely false. How about this, the next statement? If measure of angle A is 35, then A is acute. What do you all think?
This one's true.
Yeah, that makes sane. That's a sane statement. Now the next one, if A is not acute, then A is not 35 degrees. Is it true or false? True. That makes sense. It's not, yeah. But then the last one, if A is not
False.
35. False. Okay, what is one big observation here? The big observation here is
the ones with P to Q is false, and the ones with Q to P are true, other than inverse. I feel like I said that wrong.
Yeah, a little more to it. The truth value of a conditional and contrapositive are always the same. If conditional is true, contrapositive is true. If conditional is false, contrapositive is false. If converse is true, inverse is true. Converse is false, inverse is false. Does that make sense?
Yeah.
So how do I remember this? Conditional, contrapositive. Verse. The truth values are the same. Make sense?
Yeah.
Okay. So let's see this one. How about this? If you make 100 on a test, then you will get a A. That is the conditional. Next set. Since this is important, we'll discuss one more. நான் குடிக்கிறேன் ஒரு வேஸ்ட் பண்ண வேணாம் கொஞ்சம் சுட பண்ண நான் குடிக்கிறேன் எனக்கு ஒன்று போடலாம் வேணாம் if one second, what did I say, sir, guys? Sorry.
If 100, then A.
If you make 100 on a test, then you get a A. If you make 100, if you have test score equal to 100, test score equal to 100, you get A.
True.
Yep. This is the conditional, right? This is true. Good. Then the next one. We'll write all, ma. We'll write all of it. What is converse?
If you get an A, then you have a test score of 100.
That's incorrect. I mean false, because you could have a 95 and still get it.
You guys are too fast. What is it, ma? Converse?
If you have an A, then you have a test score of 100.
Which is false.
Your score equal to 100 false, okay, and then false here. This is Q to P. Then
If you don't have a test score of 100, then you don't have an A,
which
which is
is
also false.
false.
you don't get. Yeah, that is also false because 95 and all is A, right? Yeah.
And if you don't have a test score of a A, then you won't get 100.
Last
False.
one is if you
Don't
have
have an
100,
A.
have
If you,
100.
No, wait. The
no,
last
if you
one is
don't have
if
an
you don't have
A,
an A, you don't have
yeah.
100.
You don't. Yeah. See, yes. If you don't have a, you don't have a, you don't have 100. Is it true or false?
True.
True, yeah.
True. Do you see now? So you should know now. See, again, conditional and contrapositive. The truth value is exactly the same. Any questions?
No.
You got it?
Yeah.
Yes.
Conditional and contrapositive are exactly the same. Converse and inverse, the truth value are exactly the same. Can I move on? So you
Yeah.
understood how to write. If one is given, you should be able to write the other. Suppose tomorrow if I come and give you the inverse, you should be able to write the converse, contrapositive and the conditional. You should be able to write anything if anything is given. Any questions?
No.
Okay, cool. Now, what else? Okay, what is the statement that you form by replacing the hypothesis and the conclusion of a conditional with their negations? What is the statement that you form? It's just a quiz like. By replacing both the hypothesis and conclusion of a conditional with their negations.
It can either be true or false because
No,
that.
no. I'm asking for the type of statement. There are only four types. One is conditional, one is converse,
Inverse.
inverse, and contrapositive. I'm asking the statement that is formed by replacing both hypothesis and conclusion of a conditional with their negation. What is that statement?
Wouldn't it be an inverse or a
Inverse.
contrapositive?
That is the inverse of a function. You just replace whatever as is, right? P Q. You're replacing it with not P, not Q. So it is an inverse. Makes sense?
Yeah.
The next one, let's try. The statement that you get by exchanging the hypothesis and conclusion of a conditional.
Converse.
Converse. Good job. It's a converse. Good job. Okay. We are good, guys. Can I move on?
Yeah.
Yeah.
Yeah, if one is given, you should be able to write any of the other three. Okay. Similarly, you should know what are counterexamples. Proving a conjecture to be false. You should be able to prove a conjecture to be false using counterexamples. So those are the targets. Okay. Now, let's see this one. Biconditional statement. I really want you to know. Biconditional statement. What are, let me remove this. Sorry guys, last week I could not conduct the class. I had to cancel. Usually I won't cancel classes at all if it's not required.
Are you like traveling?
Yeah, I was at this Math League National Championship in Houston.
And where were you driving from?
No,
Or
I was not driving, but I was at the award ceremony of that National Math League Championship in Houston, in Austin.
Austin?
Yeah, sorry about it. Yeah, meaning I could not. I tried having it, but the program will ended only at 10:15, so it was too late. So I did not have the class. Okay, so let's go ahead. A biconditional statement is a Okay, what is a biconditional? Now we are going to combine two conditionals here. Okay, first of all, without an example, you will not understand anything here. Let's see. Okay. How about this? Okay, literally an example of a biconditional is this. Example of a biconditional is this. A shape is a triangle if and only if it has three sides. You know what is important for the biconditional? This statement, this phrase. If there is an if and only if statement, It is called a biconditional. Okay, now we are not we have not fully understood a biconditional still. Okay, when can you frame a biconditional? When can you frame a biconditional? See, let's take the same example. If a shape is a triangle, it has three sides. If a shape is a triangle, if, then, this is a conditional statement, correct? What is the truth value of this conditional statement? It is
It's true.
it's true, yeah. Similarly, what is the converse of that conditional? Converse is if a shape has three sides, then it is a triangle.
Also
That is
true.
also true. But when you look at it, this is a conditional statement, this is a converse statement. When you have a true conditional and a true converse, that is when you can create a biconditional. Biconditional is created with the phrase if and only if. So you can say if the shape is a shape is a triangle, if and only if it has exactly three sides. Make sense, guys? If you have a true conditional and a true converse, you can combine them using if and only if to form a biconditional. Make sense? It's just the words. How about this? You know how it is represented? You know, conditional is P to Q. What is the converse? Q to P, correct? You're combining both. So, how do you represent a biconditional statement? P, Q. Make sense, guys? Sham, you're good?
Yeah.
Okay. Can I move on? Okay. How about this? We'll do some problems on that. Yeah, this one is good. Okay. Let me give you this. Okay. I have given you a P and a Q. Okay, you're going to form a biconditional. You're going to tell me whether the biconditional is true or false. Let's try. What did I do? Sorry, guys. How about this? A statement I've given: x is greater than minus 2. Q says x is positive.
Mm.
Okay.
So the conditional would be if x is greater than -2, then x is positive.
Yep.
Isn't it false?
It is.
Yeah, the truth value is false.
Yep. It is a false statement.
And then the converse would be if x is positive, then x is greater than -2.
Yep.
That would be true.
That's also false.
Exactly. So let's write it down. So the conditional is if x is greater than minus 2, x is positive. This is the conditional. First of all, truth value of the conditional is itself false. What is the converse? Converse means you change that, right?
If x is positive, it would be greater than x.
-2.
-2, yeah.
Greater than negative 2, correct. That is the converse. But that is also false, right? So there is no way the biconditional can be true. Make sense?
Yeah.
So the biconditional is definitely false.
What? It says
So
if x
can
is
you still make a
positive.
biconditional or no?
What is it, ma?
Could you still make a biconditional?
You
Because
can make a biconditional, right? Because see, with a conditional and a converse, you can definitely make a biconditional. Okay, the way biconditional is made is, see here, the condition. If a shape is a
Wait.
triangle, then yama.
I have a question. I think for the second one you put it incorrect because it's if x is positive, then it's greater than -2. You put false.
No, it is
If
false.
x is positive, then if x is positive,
Then it's greater than -2. It has to be.
then it's greater than, if x is positive, then oh yeah, this is true. Good job, very nice find. I like it. I really like it. Good job, Anish.
Thank you.
Nice find. Right. What he pointed out was true. Okay. Biconditional is false. Okay. Can you write it as a biconditional? Yes, you can write it as a biconditional. If
Well,
okay.
now you can't because they have different truth values.
Yeah, but then see, you can combine both and write, right? Meaning you can combine both and write using the if and only if statement, right?
Yeah.
Yeah, so x is greater than minus 2 if and only if
X is positive,
x is positive.
which is false.
Exactly. Which is false. Makes sense? Nice. You can create a biconditional. Okay. So we are good now, I think, with this one. Okay. Biconditional statement combines a conditional and a converse. Okay. Um, okay. How about this? Okay, let's find out. I have a biconditional and a conditional. Can you just tell me the converse of it? I have a biconditional and a converse. I'm sorry, I have a biconditional and a conditional. Can you tell me the converse of this? A figure is a segment if it is straight and has two endpoints. Conditional says if a figure okay, if a figure is a segment, then it is straight and has two endpoints.
I thought it's a biconditional supposed to have an if and only if.
Yes, ma. Definitely yes. So this should have been the case. A figure is a segment if and only if it is straight and has two endpoints. Go ahead. How can you write the converse?
Converse. If there are two endpoints, then it's straight, then it's a segment.
If a figure is
Has
If
two
a figure
endpoints.
is straight and has two endpoints, then it's a segment.
straight and has two endpoints, then it is a segment.
Yeah.
Yep.
Mhm.
Okay. That's great. Okay, write each. Okay, this and all you can do. Uh, yeah, I think you can do these. Okay, I just want you to tell me this one. This is more of ACT 69. Do I have this there? No, I don't have it. Okay. 1 second, guys. I really want you to tell me the answer to this.
Okay.
One. How about this? Okay, see this one. You guys answer, okay? Let's see. Oh, I need to delete everything off. Hold on.
Mm.
1 second. Let me delete everything off. This is nice review. See whether you understood all of it, okay? You have another option here. Go ahead.
We use chat, right?
Okay, I'll wait, guys. Don't shout out. Maybe each of you answer. Try to answer. Even if you get it wrong, we'll explain and move on.
I sent my answer.
Sorry, I did not see. Hold on.
It's okay.
Really, Sham? That does not convince me, Sham. Oh, everybody says the same thing.
Yeah.
Wait, Anish also is saying the same thing. Let's see. Consider the condition. Say every eagle is a bird. A butterfly is an insect. If an animal is a tiger, then it lives underwater. So contrapositive means not Q, not, oh my god, not Q, not P. Contrapositive and conditional have the same truth value.
Mm.
Yeah, I think you're all right. Yes, Ritisha, Anish, Shyam, correct. Vishnu Ram, correct. You all got it, guys. Can I move on?
Yeah.
Yeah, I think yeah, we'll move on. How about this? Uh, how about this? Would you be able to answer this one more like that? This is related to your school level curriculum. Let's see. Uh, okay, how about this? Refer to the Venn diagram. What did I do? To the Venn diagram. Then you're going to tell me which of these. Take it as A, B, C, D, guys.
There's a thing in
Oh, I'm so sorry. I can delete it off. Hold on. That's what I wrote, right? I took it off.
I have a question about the last option choice.
Yes, ma.
Whenever it says every polygon, doesn't mean every polygon is also an octagon. Doesn't mean some polygons.
Every polygon means all polygons, right?
Okay. Yep. But I just to be safe.
So we have to say like which statements are true, right? Miss Priya?
Yeah. Which statements are, yeah, which of the following statement is logically equivalent to the Venn diagram?
Okay, I sent my answer then.
Yeah, me too.
Let me see. I don't know who did this exercise. They've done it very wrongly, I feel. Let's see. Yeah, that's correct. Yes, Maritisha, that's right. Anish, that's right. Shyam, that's right. Vishnuram, did you get it or do you need help?
I sent my answer.
Oh, you sent Vishnuram? See, Vishnuram, here, which one is right? A, B, C, D. Which one is right, Amma? A, B, C, D. Which one?
Can I just say it?
Yeah, shout out. Because
A.
A is right. Good job. Okay, as long as you get the things, great. Okay, we'll get to deductive reasoning, okay? Let me close this up. This is so distracting. Okay, now let's go ahead. Okay, I want to go into deductive reasoning. Inductive reasoning was you observed a pattern. You saw that the bus was coming to the same bus stop every week on Wednesdays at 6:10 a.m. So that was inductive reasoning. Okay, but there's one another, as I said, right? Two types of reasoning we'll use, right? Deductive reasoning. Deductive reasoning is the process of using facts, rules, definitions, or properties to reach conclusions. Meaning, you're going to make use of statistical data, facts, rules, definitions to arrive at statements. That is deduction. You make a deduction from what you know. That is deductive reasoning. Now, let's see this one. How about this? We'll see an example of deductive reasoning. If Kyle is late enrolling for summer school, basically the rule at the summer school says if you are late in enrolling, then you will be assessed a late fee of $30. It is a fact. That's the rule from the school. Kyle enrolled late for the summer camp or the summer school. Now, if I conclude that he will be assessed a late fee of 30, what type of reasoning is that? This is deductive reasoning. Yes, this is deductive reasoning because you're making a deduction based on a
The
rule.
facts.
Yeah. Okay. This part of geometry is very easy. Okay. So let's see this one. How about this? I really want you to be able to differentiate. Okay. How about this? 14. Okay. How about these two? Please don't shout out. Okay. Just send the answer to me. I just want to make sure everybody gets it. Then we are done with inductive, deductive reasoning and all of this. Biconditionals, inverse, converse, contrapositive. We learned a lot today. But then go ahead and do 14 and 16.
So we just have
do
to
you
say
think-
if they're both deductive reasoning or not.
Yeah, I want you to tell what type of reasoning is involved in each.
So it's either deductive or inclusive.
Yeah, I just want you to tell me, hey, this one is inductive reasoning, this one is in deductive reasoning, like that. If there are any difference. So you will go ahead and do this as homework for this week. You know what? I don't know. Let's see this one. This is already done. Yeah. So you will do these. What else did I leave? We did all of it, right? Deductive reasoning, finding, and then 6 practice. Yeah, definitely do this, guys. This is quite a good one. Copy. Let me put this in your homework for this week. Oh, you know what? Are we continuing with the same Google Classroom, guys? Can we continue with the same Google Classroom?
I
Okay.
got invited to like a different one.
Exactly, different one. Yeah. That's what I'm asking. Which one do you want me to put the homework in?
I would rather
I
like
don't know
the
which
same
one are
one.
we using.
Amma, with the intention that okay, we are starting a new annual year. I created the new one, ma. Do you want to continue with the old one so that we have continuity, right? What do you want me to do?
The
I'm
old
okay
one.
with the new one.
You want to move to the new one?
Yeah, I feel like then we could have geometry all in one section, algebra all in one section.
Oh, I
Yeah.
see. I see. I see. Okay, then I'll move to the new one. EOPS geometry 2000 advanced. Which one did I send it to you? 1 minute, guys. Let me quickly check.
Mhm.
EOPS geometry. Yeah, I do have it. So let me put that. People. When I see the people, I should see you guys.
Okay.
Yes, I do see you. Yes. So I will put that homework here. So basically, link is here. Okay, this is logical reasoning.
Um.
But did we do midpoint distance and all? We have not done now. I don't know.
um,
Okay, done. Okay, what did you guys do on this? Oh, nice, Sham. Nice. Mm. Hey, Ritisha, is that right? 15th?
Yeah, 15. I was confused.
Wait, could you tell me the code to join the Google Classroom, because that for some reason I can't. Oh yeah, sorry, I found it
Okay.
in the
Oh, never
emails.
mind. I get it.
You got
15
it?
is the
This,
other
yeah,
one.
yeah, yeah. This is based on a pattern, right? So this is inductive.
Yeah.
This one is based on rules. This is deductive. Make sense?
So deductive is based on rules and inductive is based on
Yep,
patterns.
yep, yep, yep.
Okay.
I have
I
more
was
questions,
just confused because I didn't hear the inductive part. So,
but you got it now, right?
yeah, I got it. Thank you.
Couple of questions. Have we discussed midpoint? See, if I follow this book, there's a lot of gap I feel. Let's see. Have we discussed midpoint fractional distances? Have we discussed? No, right? That's what I don't know, guys.
Last time, the most we talked about were like proofs, theories,
Yeah, yeah. No,
and
no,
stuff
I'm
like
just
that.
following blindly the book. So maybe, see, guys, I don't know. We are going to take time because I want to really work on these. These come as a part of your school syllabus as well. Okay, fractional distance is also important. Okay, so let me do one thing. Next week when we start the class, right, we'll do midpoint partitioning line segment, fractional segments. Okay, and then we'll do distance. Okay, then we'll move on. Okay, meaning we'll do all the three. Midpoint is if a line segment is given, finding the midpoint. Okay, that's very easy. Meaning if you have -2, if you have a 5 in here, what is the midpoint? How will you find the midpoint? -2, you have 2, you get to 0. Here 2 means you get to 3. Then
Is
what is
1.5.
1.2? So how do you find it? So basically what you do, -2 plus 5 divide by 2 is what you do. Correct? Starting point, ending point, divide by 2. So when you have 2 points x1 comma y1 and x2 comma y2 in a coordinate plane, see, this is just on the x-axis, right? On a coordinate plane, if you have 2 points, right, this is x1 comma y1, this is x2 comma y2. How do you find the midpoint? Pretty much easy. Midpoint is x1 plus x2 by 2 comma y1 plus y2 by 2. So like this, there are some basic geometrical concepts which we have not covered. I feel like we are lagging on that. So I really want to cover this and then only continue with congruences, similarity. Make sense?
Okay.
Make sense? Yeah. The for those I'll give you separate assignments. Make sense, guys?
Yes.
Yeah.
Okay, I'll stop here for today. You know what? We are not going to have that 30 minutes extra, as I said, right? Let's have the others join, and there are 3 others who have not joined in at all. So maybe next week as well, we'll not have it, but I will remind you guys. Please make sure we will have it the week after next. Any questions?
No.
I just want
No.
all of you to be present. Okay? Yeah. Any questions for me? Any other questions for me?
Aye.
Okay, I've already assigned the homework on logical reasoning for today. Next week, we'll continue these things and then only continue with the chapter 3 of congruence. Okay?
Okay.
Okay, guys. See you all. See you all next week. Have a nice week ahead. Enjoy the summer as well.
You too.
You too. Bye bye.
Bye.